Hey everyone, today we're going to talk about bringing a little bit of order to the beautiful chaos that is modern software. We're going to explore how you can actually orchestrate all the different moving parts of your application, not by writing more code, but by using a visual workflow. So how do we do that? Let's dive right in.
Really, just think about that for a second. What if instead of writing all this complex, error-prone code to manage a business process, you could just draw it, like a flowchart? That's the fundamental idea we're going to unpack today with AWS step functions.
Okay, so to really get why a tool like this is so powerful, we have to first appreciate the problem it's solving. And that means we need to talk about the reality of building apps today, which can often feel like the chaos of code.
You see, today's apps aren't these single giant programs anymore. They're built from microservices and serverless functions like AWS Lambda. You can think of them as these little specialized workers. You've got one that handles payments, another that processes images, a third that sends out notifications. They are incredibly powerful and scalable, but this approach also creates a brand new challenge.
And here is that challenge. How do you get all of these little independent workers to collaborate on a single complex task? Well, you end up writing tons of what people call glue code, just to coordinate everything. And this code, it has to handle errors. It has to retry failed steps. It has to manage the whole sequence of events. It gets tangled fast, and it becomes a mess that's hard to build, nearly impossible to see into, and a total nightmare to debug when something eventually goes wrong.
So, faced with all this potential chaos, how do you bring order to the system? Well, you hire a conductor. And in the world of AWS, that conductor is what's called a state machine. This is the absolute core concept behind step functions.
A state machine is, pretty much what it sounds like. It defines all the possible states your process can be in, things like process payment, check inventory, ship order, and all the rules for how to move between them. It's a visual map of your logic that directs all your individual services, telling each one what to do and when to do it. It basically turns that tangled mess of glue code into a clear, visual, manageable workflow.
And the model itself is just beautifully simple. It all starts with the overall workflow. That's the whole process, from A to Z. That workflow is then broken down into individual states. And a really common type of state is a task, which is where you call out to another service, like a Lambda function, to actually do some work. It's this really clean, simple hierarchy.
All right, now that we've got the basic concept down, let's get into the really cool stuff, the features that make step functions so incredibly powerful. Because these aren't just simple flowcharts. They come with some serious superpowers for building rock-solid applications.
First thing you gotta do is choose your workflow's personality. Do you need patience and precision, or do you need raw speed? Standard workflows are your marathon runners. They can run for up to an entire year, they keep a detailed history of everything, and they guarantee that each step runs exactly once, perfect for something like processing a customer's order. On the other hand, you have express workflows. These are the sprinters. They are built for super high-volume, short tasks. We're talking up to 5 minutes. They're wicked fast but offer an at least once execution guarantee. Choosing the right one is a really critical first step.
Now let's talk about efficiency. Here's our first superpower, the parallel state. Instead of just waiting for one task to finish before you start the next one, you can run multiple branches of your workflow at the exact same time. So, for example, when a user uploads a video, you could kick off processes to encode it into 3 different resolutions simultaneously instead of doing them one by one by one. It's a massive time saver.
And for our second superpower, we have the map state. And this is an absolute game changer for data processing. Let's say you have a list of items, maybe thousands of images sitting in an S3 bucket. The map state lets you run the same set of steps for every single one of those items, all in parallel. It is literally like having an army of workers to process your data almost instantly.
So just how big of an army are we talking about here? Well, the distributed map state can launch up to 10,000. That's right, 10,000 parallel child workflows running at the exact same time. This is how you process absolutely massive data sets, things like genomics data or millions of user photos, with incredible speed. Okay, so these superpowers sound really cool in theory, but where are people actually using this stuff? Let's look at a couple of tangible, real-world examples and see how step functions can transform these super complex processes into workflows that you can actually manage.
First up, and this is a huge one, machine learning. ML pipelines are notoriously complex, right? They involve all these different steps of preparing data, training models, deploying them. It's a perfect use case for an orchestration tool.
So with step functions, developers can automate that entire ML lifecycle. You can build workflows that automatically pull in and enrich data to make your models more accurate. You could string together services to detect fraudulent credit card transactions in real time, or you could even manage the incredibly complex process of labeling objects and images for computer vision. It just brings so much structure to the world of AI. All right, next up, let's talk about big data. As organizations are collecting more and more information, the challenge of actually processing it all efficiently becomes absolutely critical. And this is where that map state superpower we just talked about really shines.
People use step functions all the time to coordinate these massive extract, transform, and load, or ETL jobs, where you're pulling data from all over the place and preparing it for analysis. Think about processing millions of uploaded photos to create thumbnails, or running huge batch jobs for scientific computing, or even automatically combining sales and marketing data to generate those critical business reports. It really does tame the big data beast.
So let's bring this all home. We've seen the problem, the chaos of code, and we've seen the solution in these visual workflows. So what's the core advantage here? What does this actually mean for you, the person who's building the application? Here's why this really matters. First, visual debugging. When an execution fails, you can literally look at a graph of your workflow and see the exact step that failed, highlighted in red. It is so intuitive. Second, error handling is just built right in. You can configure automatic retries or define custom fallback logic without writing a ton of complex try-catch blocks. And what this does is it lets you focus on your business logic, not the plumbing. And ultimately, that helps you build applications that are way more resilient and fault-tolerant. So, by transforming that tangled web of glue code into a clear, visual state machine, step functions lets you truly conduct your services, not just code them. And that kind of leaves us with a really interesting question to think about. As you consider your own projects, what is the first complex process that you would choose to draw instead of to code? Thanks for tuning in.